This here is my own special brew. This is basically my modified version of a Altec 436, 438, same circuit compressor. This is a Vari-Mu compressor that was used by the Beatles, and the Beatles version was heavily modified too by the engineers at EMI. So I like what the EMI guys did. A couple years ago, someone finally revealed, I guess, what was accepted to be the real mods for that circuit. And I built basically that model before, and I really liked it. This one is the evolution of a few tweaks of mine, and it's funny, even though I just finished this one, which is the first time I've built this actual model with these tweaks. There's a few others I want to change for the very next one that I build. I mean, this one's still very cool, and it has all the mods up until 2 days ago. So anyway, there's a few little tweaks I want to put on this thing just for a little more flexibility, but it wouldn't really affect too many people. I'm just obsessed with getting the most out of the least. All right, and that's why I use these recycled boxes. See, check these out. All right, I got these. These used to be Akai / Roberts. Same thing. They just called them Roberts in the U.S. in some places because people were still pretty racist against Japanese, and Akai sounded too Japanese. Same reason Datsun was Datsun instead of Nissan. Anyway, so I use these chassis, and I tear them down. This starts as a tape machine. Here, I'll show you a face of one of them. Starts as a tape machine. Usually they're 2-channel. Most of them are 2-channel, but there are 1-channel ones. And there's a few different circuits and a few different models, but when they're torn down, they basically turn into the same thing. And some of the sockets are different. Some of them have 7-pin or 9-pin. Some of them have 4 sockets. Some of them have 5, depending on if it's a left or a right channel. When they were a stereo unit, they only had 1 tube dedicated to erasing both channels. It was essentially a power tube that they had set up as an oscillator to just erase both channels. So they didn't have to put one on both channels. Okay? All right, so anyway, I started with one of those, and I tore this down, and I painted it, and I drilled it, and I got this meter. Man, I shouldn't tell you guys where I got this meter because then they'll all dry up. But whatever. I get this meter from the Yamaha PM1000 consoles. Here, I've got one right here, another one. I got like 5 or 6 of these, so I'm probably good. PM1000 consoles. A lot of people will take them apart and part out the individual channels and then rack them up. So I was, like one day I was parting out one of these and I was like, you know, that meter looks really close to the same size as the ones that go in here, the original stock ones. And so the original stock ones that come in here are pretty, this one isn't the right size, but it's from another different model. I don't really have one handy. Anyway, these are junk. As far as like, they're not a real VU meter. They're mostly a toy. They don't really measure anything very accurately. Like this 0 whatever is pretty arbitrary. Because these are speaker level. So you have to have like multiple watts of output to drive these things. With just a regular line level output, they don't even move. Anyway, half the time these are broken anyway. Or I would say more than half the time. People ask me, oh, make sure I get a good meter. I'm like, I can't guarantee anything. And honestly, these things are so, I mean, they're still so much better than anything you could probably buy new. If they make speaker level VU meters anymore. Anyhow, after 50 years, most of these are busted. I think they have really fragile parts inside. I don't know. Whatever. These are much more robust. I've gone through about a dozen of these and none of them have been broken. A lot of the lights are burned out. It has 2 little lights in it. And originally it was fed 12 volts for the lights. I'm feeding it 5.7 volts from a separate tap on this transformer, which is really nice. Anyhow, so this is from a PM1000 console. It fits right in there. Yeah. So essentially this whole thing is Japanese. The Japanese Akai chassis, or the transformers, well, the power transformer. Here, I'll go around the back and we'll look at that too. Around back, we've got, around back we've got this Akai-made transformer. Some of them have had the brand of Orion before. I don't know, something Japanese. I'm not that familiar with Japanese gear outside of the Akai stuff. All right, there's a choke. And then I add EdCore output. Now this is a really beefy transformer. This is a 15K to 600 output. The cool thing about this one is you can apply B voltage to the pin 3. Yeah. And then I've got an EdCore for the input, and I go with a 10K to 15K for a slight step up. The 10K input is different than what this thing would have originally had. Pretty sure originally the circuit had a 15K to 80K center split. It's that center tap that makes it hard to apply a newer transformer. There's not a lot of 15K to 80K. It's pretty specialized. No one really makes it anymore. I mean, you can match up the ratios. Basically what I've done is I've given it a slight step up from 10K to 15K. And it seems to work with just about any kind of input. I mean, you don't want to plug a guitar directly into it or anything stupid like that. Well, you maybe could have done that with the original. I don't know. Okay, so let's go back to the choke real quick. That is something that was not in the original design. The original design uses a solid-state power supply with a 1-to-1 power transformer. See, this one's a proper, I don't know what the ratio is, but the secondary is 250-0-250, which means it's 500 center tapped. Okay? So that puts out, after going through a tube rectifier, I've got a 6X4 right here. After going out of there and going through the choke, it's right at about 300 volts, which is perfect. It's what the circuit wants. It's a little more than the circuit wants, so I have to knock some of it down, but it's always better to have more voltage than you need, because you can always make it less. But it is hard to make it more. And that's the whole thing. I like this power supply a lot better than that original stock Altec one. Certainly these parts are more expensive, and that's why they didn't do it. You know, the Altec design originally was for a PA. So recording with it is already kind of like, they're like, well, that wasn't really its intended purpose. I mean, I think it works good. I like this design. I like this circuit. It's simple. Sometimes just as a line amp, it's great, you know, with the compression turned off. And I'll go around the front. There's only a couple of features on the back. First of all, I got the old school attached power cord. You know, this one's actually a vintage piece. I think it's made in USA, but it's in great shape. Anyway, then I've got this breakout here. I don't have the actual breakout cable with me. Here's a header that fits it. These come in the Akai and Robertson. I like to reuse them because they're right there. So take a guess what this is for. All right, on the front, I've got balanced 1/4-inch inputs. Well, I've paralleled those jacks with this so that I can actually have a header that goes out with a balanced input and a balanced output to XLRs. So the XLRs and the 1/4-inches are in parallel on this design. That's actually one of the changes I'm going to make on my new one is and I'll get to that in just a second. Because of the nature of the output pad, I'd like to have the front 1/4-inch jack be wired slightly differently. Maybe I'll post a schematic showing you guys what I want to do on the next one. It occurred to me as I was finishing building this thing as like an alternative. Here, okay. So that's the back. Input transformer, output transformer, choke, and main power supply transformer. All right. All right, now up front, sorry my shop is so messy. I have been spending days perfecting this thing and have not kept it clean. So over here, we've got a hold switch. Hold is great. Basically, where the release circuit, which discharges the capacitor. All right, let me go for a second over the design. Vari-Mu essentially takes a signal from the audio circuit. So the audio comes in, it goes from the first stage to the second stage. The second stage, they tap the second stage right where the output is, send it to 2 diodes, which in this one is a 6A05, the tube that acts as 2 diodes. And it sends it to those diodes, and it gives you a rectified voltage that is then fed back into the grids of the first stage. And the first stage is what's called, is it remote cutoff? Yeah, I think it's remote cutoff. Remote cutoff just means that an outside voltage will adjust the gain automatically, thus compressing. Pretty cool. It's not the fastest thing in the world. It is kind of squishy in how it responds, attacking and compressing, and then releasing. But I like it. For vocals and bass, man. You know, the real famous sound of this is the bass sound. All right, if you listen to the Beatles, obviously people that are obsessed with the Beatles are going to know exactly what this thing is. The sound that I always point out to people, which was pointed out to me, who knows what they actually did in the studio, but it's an awesome sound, and I've had a lot of people verify it. Anyway, the song Rain, you listen to the bass line, Paul's bass line in Rain, that really shows it. And I'm pretty sure that's what the hold function. So basically this what this does is the loudest compression level that you hit, it stays there because there's nothing to discharge it, right? Sorry, I wasn't filming that. The hold function. When I flip it up, it removes the ground from the release circuit, so it doesn't release anymore. It effectively doesn't attack either because it's always on. It stays on. Hold will keep it on. It'll hold the function. Okay? Pretty easy. Compress. That's pretty simple. Oh, man. Sorry. I'm looking at what I'm filming and not looking at the camera. Sorry about that, guys. All right, so compress, on, off, pretty simple. When I flip it up, it compresses. When I flip it down, it's just a regular line amp. And I have it wired so that when this is in this position, it actually grounds the circuit that's feeding back voltage. It grounds the capacitor. So that if, all right, say I've got hold on, right? And then I have compression on, right? Well, if I want to reset the hold but not turn it off, I can do this and it'll recharge. But see, each time I turn it off, it grounds it. So it's like adding this back in. It's a little weird. Never mind. Actually, you know what? I think that's the second change I wanted to make. I think I do want... Never mind. Okay, so let's just go to this. Basically, compression on-off. Input. This input is a 1/4-inch TRS jack, which means you could plug in a balanced cable to it. It's paralleled with an XLR that goes to the header. You can also plug in unbalanced, because it'll just ground out the negative pole of the balanced circuit. Okay? And then I've got... Let me go down a little further. Here are the controls across the front. I've got attack, which is obvious. That's how fast the attack is for the compressor. All the way to the left is the fastest. All the way to the right is the most. It's the slowest. So, you know, I kind of debated that for a while. Like, which way should it actually rotate? Should this be faster? Or should this be faster? I don't know. I mean, am I increasing speed or am I increasing resistance? I went with increasing resistance because that makes more sense. It's a freaking pot. Okay, so this is your fastest setting, and they're linear pots anyway, so it's not like it's going to change the curve. All right, then I've got release. Release goes the same way. This is the fastest release, and then this is the slowest release. Okay, I tend to like it on vocals and stuff about right in the middle, or with drums and stuff. I like to have it a little faster. You know, and bass. Yeah, you know, maybe a little more. I don't know. All the way up is kind of extreme. I usually don't go past about here. But it's useful if you really want. Like if you were doing like some really slow synth work or something, it would probably be pretty useful. I haven't really used it in that fashion yet. Anyway, so the meter here, this is a zeroing out thing for the meter. It works especially well with this. This is a gain reduction switch or an output switch. And this also goes to the meter. When it's an output, it's measuring the output, and it goes from here to here, whatever. When it's in gain reduction mode, the needle actually jumps, and this meter control here helps zero it out. So basically what you do is you put it in gain reduction, and then you turn this until the needle is on 0. And then when the signal goes into it, this will actually measure the amount of gain reduction by going backwards. Boom, boom, boom. Pretty neat, huh? And then here we've got attenuation. That's just essentially your input attenuation. This is after the input transformer. So this is kind of interactive with the amount of compression you get, because this is how much signal you let hit the circuit, right? So you can turn it down and it'll hit less. And then the threshold obviously works with that. The threshold goes from a low voltage to a higher voltage reference, and that determines where it starts pushing the compression voltage back down. Pretty simple. What you don't really have is a ratio. Ratio is pretty much determined by the tube itself, I guess. I don't know. Vari-Mus just don't have ratios. Not a true ratio. All right, and then over here, this is new on this one. It's the first time I've built this, and I love it already. So the output of this circuit is rather hot. Whether it's being used as a line amp or as a compressor, it's rather hot output. So it is. I've struggled with some digital setups that it just decides to, no matter how I calibrated it, it would ping it. So I had to a couple of models ago. Actually, I think I built them all with pads, but when I was prototyping them, I had the original prototypes without any kind of pad, and it was just too hot sometimes. Like, it worked great with tape, because tape will just swallow up all that signal. It worked good with guitar amps, because obviously you can just more gain just was more gain. It'll swallow that up too. So if I was going into other tubes, it was fine. If I was going to tape, it was fine. It was still hot, but digital, it was just barely. When I'm snapping my fingers, I'm talking about like that moment where it's just like the tiniest little clip. Okay. It clipped pretty heavily too, depending on what you were sending it. So, all right. I used to have a fixed pad, which was just a switch. It was about a 20 decibel pad. You flip it up, 20 decibels down. It was usually pretty much enough. In some cases, it was a little too much. And it actually got to the point where if anybody was recording digital, I was like, just leave it on all the time. So it kind of limited the amount of overall gain you could get from this thing without clipping. I like to maximize, everything. So I saw this circuit. It was another Vari-Mu compressor, which also had its own hot output. Anyway, the circuit's really awesome. It's balanced. It's a balanced attenuator, what they call an H attenuator, where it's got a pair of resistors in line of the balanced signal. Then it has a fixed resistor and a pot in series across those, and then it's got two more fixed resistors going on the out. And basically it presents an impedance that stays close to the 600 ohm output that this thing has. But it adjusts, but basically this adjusts from 0 to 1000. Okay, when it's all the way at 0, the fixed resistor is 60. So it presents it with like a 600 ohm load. And as this goes up, the load goes up. And effectively what it does is it just damps the output. I'm sorry, when I turn it up, it gets lower. When I turn it down, it gets higher, more resistance. So basically, this acts as my limiter to the limiter. I will send the hottest possible signal through here. I'll have it compressed, not compressed, and then I'll check it with this, and I'll set the trim wherever it doesn't clip the digital anymore. Voila! So here's the other, and here's the output. The power switch here. Here's the output, and it's currently the way I have this design is this is paralleled with the XLR that goes to the output. Cool, right? So here's the change I want to make, and it may be experimental. I'll definitely try it out on my own before I sell any of them. But basically, I'd have this output wired first. So okay, I'd come out of the output transformer, and I'd go directly to this thing, right? Then from here, I would have my pad go to here, and then the output of the pad would actually go to here, and then that would go to my XLR. My reasoning for this is currently this design, you have to use a balanced cable, a balanced output, right? Because of the nature of the balanced output pad. I mean, it will give you a signal with an unbalanced cable. I need to experiment with that, but it's not going to be ideal. Like it's a balanced attenuator circuit. So the way that it's wired is this thing won't ground properly the unused signal. I'm not sure that it just is not good. Anyway, so this needs to use balanced for the XLR or for this. The mod that I want to have would change this so that when you ground this out, it actually does ground to the transformer itself, thus making the transformer unbalanced. And that way I could put a regular 1/4 inch cable in here and feed that into a guitar amp. Okay? You know, you could still do that. It's just the attenuator is going to act, it could act funny. I don't know. Now, the attenuator would still work on this because, with the mod that I'm proposing, the attenuator would still work. It wouldn't work as much as it does on the XLR output, but you're still changing the load across the output, even because it's still wired in. You know, there's still wiring post this jack, which still closes out the circuit. Anyway, so that's it. Man, I talk a lot, don't I? Fuck. Oh, and now I'm cussing. Great. I just demonetized this whole thing. I have to beep that out. Well, y'all, so this is my Tablebeast TB-A436. I like it, and I hope you like it too. Oh, you know what? I almost forgot. There is one little thing. This is a balance circuit right here. This little thingy. Basically, one pot adjusts voltage. This one adjusts the high voltage. Sorry, man. I'm just gross today. This adjusts high voltage going to the plates of the first tube. And then this adjusts the cathode balance, also going to this tube. These allow you to make sure that the Vari-Mu tube that you're using is well balanced. That way you don't get any low frequency thumping. If you have ever heard thumping before, you know what it was, and it's not very pleasant. People don't like it. It's kind of like types of distortion that aren't pleasant. I just don't like it. Anyway, so this helps you balance it out. The tube that I've got in there was already pretty well balanced. But there you go. That should be all the functions. Hope you like it. Yeah, I almost forgot to show you guys the guts. I mean, come on, this is the porn. This is the good shit. Alright, so this is all the wiring and stuff. I know, it's a mess, isn't it? Such a simple circuit, and yet, blah, look at all that stuff. Basically, here's my input jack, here's my compression switch, all the controls from the back. You can see the wiring, the first tube, the output tube, and the rectifier tube for the signal, and then the rectifier tube for the voltage. Over here I've got my big old 1UF cap. This is the actual compression cap that charges and discharges. This is how you adjust the attack and release, is with this guy. And then I've got a little filtering stage that goes with the input transformer to kind of smooth things out. It also knocks out some super high frequencies, just so we don't have to worry about it. And then the size of these caps right here knock out a lot of those super low frequencies. Now this thing has still got a great bass response, but it doesn't get super flabby and doesn't go like deep. I mean, you could get it to go a little deeper with some bigger caps, but then... See, compression has a way of taking over, or low frequencies have a way of taking over compression, So, I guess I could make a bass version of this, and it would be a little different if it was specifically targeted at, like, even stuff below a bass guitar, like below 80 hertz. This is awesome up till probably 60, So it's really just the deep stuff that it doesn't get. But that's by design, just so you know. This knocks out like stuff over like 40K. It's no big deal. This is the plate resistors for the first tube. This is the part of the this is part of the output pad. This is the circuit that feeds back the signal from the output into the rectifier tube, which turns the voltage into the Vari-Mu voltage. Pretty simple. I have an extra filtering stage. Normally it would have just been a single 10K resistor and a single filtering stage for the audio tubes. But I don't know, whatever. I thought I had the space. I added an extra filter cap. So it's 5K, 5K, and then 2 instead of a single 10K and 1. Let's see, got a big old 6.5 watt. This is the big resistor that goes to the output circuit. Because it actually it rides 2 separate voltage rails. This rail goes to the second tube, and this rail gets filtered twice and goes to the first tube. Then, of course, I have a big old 40 UF, which sits after the choke, and then a small 10 UF that sits before the choke. That way I don't stress out my 6X4. And I still get the filtering capability. Eh? Alright, then I've got I think it's a 1 amp fuse. Yeah, 1 amp fuse. And then I've got my power cable. And it's grounded to the chassis right there. Ooh, got a little drawing going on there. I've been doing this lately on a couple of these. A lot of times this is just going to be covered up. But it's fun to know that there's a neat little drawing in there. And I'm sure years from now, someone will look at it and say, that's cool. Maybe. Who knows? That's it. Dang it, that's not it. I have one last thing. So, this was the last little, it's like a shield. It's not like a shield. It is a shield, but I'd put a little drawing on there just to be fun. The guy that I've made this for, man, God bless him, he has been patient as can be. I've taken a while to get this to him, but man, I really hope that the quality of it makes up for the long time that it took. Because this thing is awesome! Alright, so you can see this thing working. See the VU meter? See how it's centered on 0? Yeah, we'll zoom in a little more. See how it's centered on 0? Right now, it's in gain reduction mode. See the gain reduction mode switch? And then the meter knob, which zeroes it out. And then check it out. This is with the attack and release at its lowest. You can see how fast it works. Not bad. Really awesome for vocals. Yeah. And you can see here I've got the attenuator up and the threshold down. So it's pretty much compressing all the time. Somewhat, a little bit. So I can change that. See where I've got the trim. You can see where my input signal is. Probably peaking out at like -6. Below 0. That's where I like my signal to go. I can get it to compress more here. This up a little bit. Put the threshold all the way up, and that all the way up. Let's see what I can do now. See? Now the signal's a little too hot on the output. Clipping. So I'll adjust that down just a hair. Should be enough. Show you with the compression off, and obviously the gain reduction doesn't work anymore. I'll go and show you with the output. So remember, +3 analog is what? -12 digital. So. So, one reason why I have the switch set up with the center off, and I'll show you that, is because sometimes the signal is so hot you're like, man, I'm going to break my VU meter. I don't think you're going to break this one, but see, now it just is off. Anyway, so if you're making a lot of noise, you don't want to mess with it. But then you want to turn it on. Alright, so it's out of compression mode now. So, alright, if I put it in gain reduction, it won't do anything. Because essentially the voltage that is there to compress is grounded. Essentially. So nothing happens. Flip the compression switch. Please note, I am not a musician at all. There's a reason why I build gear. It's because I can't play music worth a shit. Get that? Alright, hope you guys like it. My TB-A436 and the fellow that's going to. I hope you enjoy it. You will have it very soon.